Okay, so I want you to picture a scene. It's the absolute classic trope from, well, every police show, every spy thriller you've ever seen.
Oh, I know exactly where you're going with this. I can already see it.
You know the one, right?
Yeah.
The detectives are all huddled around a monitor in some dark room.
Yep, and the suspenseful music is humming in the background.
Exactly. And on the screen, there's this security camera footage. It's grainy, it's dark.
Yeah.
The suspect is basically just a blob of gray pixels. You can't see anything.
It could be a person, could be a smudge on the lens.
Right. It's totally hopeless. Until the lead detective leans in, narrows his eyes, and yells that one magic word.
Enhance.
Enhance. And the tech guy taps on a keyboard for like 3 seconds, and suddenly, boom.
Crystal clear.
That blurry gray blob transforms into a high-definition portrait of the bad guy. You can see the pores on his nose.
It is the ultimate Hollywood cheat code. It's great for drama, but I have to tell you, it drives computer scientists absolutely up the wall.
But that's exactly why we're here today. Because we see that and we think, okay, that's fake. But then, we open our phones with Face ID. We hear about smart cities.
Right.
So it really begs the question, is that scene just movie magic?
Yeah.
Or can AI actually do that? Can it take a terrible CCTV image and tell us exactly who that person is?
Well, the short answer is, the movies exaggerate the visual part, but the identification part, the reality is surprisingly close.
Really?
And honestly, the real process is sometimes even creepier and way more mathematical than what you see on screen.
Creepier than a magical zoom button.
Okay.
Okay, I am hooked. What are we diving into today?
We're going to strip away all the sci-fi hype. We're looking at the actual mechanics of facial recognition.
Fine.
We're going to break down the specific math it uses, the tools that are actually free and available to anyone right now. And this is the part that always fascinates me. How it can identify you even when it can't see your face.
Right, it can identify you without a face.
We will get to that. It's a total game changer. But first, we have to get our heads around the core concept. An AI doesn't see a face the way you or I do.
Right.
It doesn't look at a photo and say, oh, hey, that's Steve. It calculates Steve.
It calculates him. That is a very specific and slightly unnerving way to put it.
It is. And that's where we have to start. When you look at a face, you see personality, emotion. A computer just sees a landscape of data.
So let's start at the beginning then. If it's not seeing eyes and a nose, what is it actually doing?
It's converting the pixels of an image into numbers, geometric data. It really isn't magic, it's just math.
Okay.
And it typically follows a standard 4-step workflow. If you can understand these 4 steps, you basically understand every facial recognition system out there.
All right, lay it on me. Step 1.
Step 1 is simply face detection.
Which sounds pretty self-explanatory. It finds the face.
It sounds simple to us, yeah. And that's because our brains are basically wired to see faces. I mean, we see them in clouds, in burnt toast, electrical outlets.
Right, everywhere.
Exactly. But for a computer, a video frame is just a grid of colored dots. It has to look at that grid and figure out what's the human face and what's the brick wall behind it.
So it's drawing a little box and saying, this bit right here, this is the human.
Precisely. And it does it by looking for contrast patterns, dark spots where eyes usually are, a lighter spot for the bridge of the nose. Once it has that box, we move to step 2, normalization.
Normalization. That sounds a bit clinical, like making something average.
In a way, yeah. I mean, think about CCTV footage. It's almost never a perfect studio portrait.
Right, nobody poses for a security camera.
Exactly. The person might be looking down at their phone, or there's a weird shadow, or the camera's way up high on a wall, catching them at a sharp angle. So if the AI tried to compare that a raw, tilted, shadowy image to, say, a clean passport photo in a database, it would just fail. The math wouldn't line up. So normalization is just standardizing that image.
How does it do that?
It digitally manipulates it. It might turn it to grayscale to remove lighting issues. But the big thing is it digitally rotates and stretches the image to make the eyes level and the face forward facing.
Oh, so it's like it's digitally grabbing the person's chin and tilting their head up to look straight at the camera.
That is a perfect way to visualize it. It's just tidying up the data before it starts to read it.
Okay, so we found the face, we straightened it out. What's next?
Now comes step 3, and this is really the core aha moment of the whole technology. It's called feature extraction.
This is where the measuring tape comes out, metaphorically speaking.
Metaphorically, yes. This is where the AI stops looking at the picture and starts looking at the geometry. It measures specific distances.
Like what?
We're talking the precise distance between the pupils of the eyes, the width of the nose, the shape of the cheekbones, the curve of the jawline.
I've heard about this. It's basically mapping the face.
It's mapping the geometry of the face. It's looking for what we call nodal points. A human face has something like 80 distinct nodal points.
And it's measuring the relationships between those points.
Exactly. Ratios. For example, how wide is the mouth relative to the width of the nose? How deep are the eye sockets relative to the brow line?
And those ratios, they don't change, right? Even if I smile or frown or something.
That is the key. Your expression changes, sure, but the distance between your cheekbones, that's fixed. The underlying structure of your skull doesn't change from moment to moment.
So it's ignoring my smile and looking at my bones.
Precisely. And that takes us to the final step, step 4, matching. The system takes all those measurements and converts them into a unique code.
A code, like a password.
More like a long string of numbers. In the industry, we call this a face print or a feature vector.
A feature vector, that definitely sounds very sci-fi.
But it's just data. Think of it like a barcode at the supermarket. The scanner doesn't care what the cereal box looks like.
Right, it just needs the lines.
It just scans the barcode. That feature vector is your facial barcode. It's a string of numbers that represents you mathematically. And once the system has that, it doesn't even need the picture anymore.
So when it's identifying me, it's not comparing my photo to another photo.
No. It is comparing your number string to a database of millions of other number strings. It's just checking a list. And because computers are so fast at comparing numbers, it can scan millions of faces in a fraction of a second.
Wow, that's wild. It really is just deconstructing your face into a spreadsheet.
Exactly.
But okay, this brings us back to the whole Hollywood thing. That 4-step process sounds great if you have a decent image. But what about the enhance button? What happens when the CCTV footage is a blurry mess? When the barcode is all smudged?
This is where the technology has made these massive leaps in just the last few years. You'd think that if a human eye can't see the details, the AI can't either. But remember, the AI isn't looking for details the way we are.
It's looking for structure.
It's looking for structure. It can infer things from the blur. Even if a face is blurry, the underlying facial structure, the bone alignment, that doesn't change.
We're back to the skull again.
We are. The way the skin sits on the bone, the geometry of the hairline, these things stay consistent even when the resolution drops. The AI can find patterns in that fuzz that our eyes just miss.
So it's basically looking for the skeleton underneath the pixelated mess.
In a sense, it uses a technique called facial landmark detection. It tries to find anchor points.
Anchor points.
It's like the corners of the eyes or the edge of the mouth. Even in a really low quality image, there's usually just enough contrast for the computer to find these specific points.
Okay.
And if it can find, say, the corners of the eyes and the tip of the nose, it can mathematically triangulate where the rest of the features probably are.
He's connecting the dots.
Yeah.
But what if the dots aren't even there? What if the image is just a blocky Minecraft-looking mess?
Then the AI starts guessing.
Guessing. That sounds a lot less scientific.
It's a very, very educated guess. This is where we get into something called GAN-based reconstruction.
GAN?
It stands for Generative Adversarial Networks.
Whoa. Okay, big words. Break that down for us.
Okay, think of it as a competition between two AIs. You've got one AI acting like an artist and another acting like a really strict art critic.
An artist and a critic. I like it.
The artist AI has studied millions of photos of human faces. It knows what a nose generally looks like, how light usually hits a cheekbone. So when it sees a blurry image, it uses those learned patterns to fill in the missing pixels. It tries to paint a clear image based on what's probably there.
And the critic AI.
The critic looks at the result and says, nope, that doesn't look like a real human, or that looks fake. And they go back and forth millions of times until the artist creates a face that's so realistic the critic finally accepts it.
So it's not really enhancing the original image. It's rebuilding it based on what it knows about faces in general.
Precisely. It's filling in the blanks with probable data. There's also another technique called super resolution, where it mathematically guesses what information exists between the pixels.
Does that mean the face it creates might not actually be the real person?
That is the catch. It might generate a face that looks 100% real, but it's a probable face. It's the AI's best guess. But often, that guess is just accurate enough to run a search and find a match.
Okay, so we've dealt with the blur. But what if the suspect is smart? I mean, what if they're wearing a mask, a hood, big sunglasses? What if the face is just gone?
And you would think that just defeats the system, right? If the barcode is covered, you can't scan it.
Yeah, exactly. No face recognition.
But here's the twist. This is the part I mentioned earlier that kind of blows my mind.
Okay.
AI doesn't even need a face anymore.
Here, babe.
It can identify you by your gait?
My gait? Like the way I walk?
Yes, your walking style. It turns out the way you move through space is a unique biometric trait, just like a fingerprint.
You're telling me the way I walk to the fridge is unique enough to identify me on a camera?
It is surprisingly unique. Think about it. It's a combination of your body mechanics, the length of your bones, your posture, how flexible your hips are.
Right.
The AI analyzes your movement speed, the length of your stride, the swing of your arms, even the little bounce in your step. It's analyzing the physics of your body in motion.
So even from a distance or from behind, where you can't see a face at all.
It can track you. It maps your silhouette as it moves and combines that with your unique movement signature. So putting on a mask might hide your nose, but unless you, I don't know, put a rock in your shoe to change your walk, the system can still probably flag you.
I feel like there's nowhere to hide. That is officially the creepier than the movies part. But let's ground this back in reality. How well does this stuff actually work? What are the real numbers?
This is where we need a bit of a reality check, because the sales pitch and the real world are two very different things.
What's the sales pitch?
Well, the companies selling these systems will often claim 99% accuracy.
Which sounds pretty much watertight. I hear 99%, I'm thinking it's flawless.
In a controlled lab environment, sure. If you're standing still, perfectly lit, looking right at the camera, the airport passport control scenario.
Right, where they make you stand the little footprints.
Exactly. But in real world conditions, moving crowds, bad weather, weird streetlights, the accuracy is often closer to 84.9%.
84.9?
Yeah.
Whoa, that's a massive drop. That's a 15% error rate.
It is, and you have to understand that AI deals in probability, not certainty.
What do you mean by that?
The system doesn't pop up a window saying, this is absolutely John Smith. It gives what's called a confidence score. It'll say, I am 85% sure this is John Smith.
So it's hedging its bets.
It's all just statistics.
Yeah.
And there are so many things that can lower that score. Environmental factors are the big ones.
Like what?
Poor lighting is the enemy of data. Deep shadows under the eyes can throw off the measurements. Extreme angles are another one. If a camera is mounted too high, it distorts the geometry of the face.
That makes sense.
And even physical changes matter. Aging is a challenge. But also simple things like heavy makeup, growing a beard, even wearing glasses that reflect light can confuse the system. They hide those anchor points we talked about.
So it's powerful, but it's also fragile. It needs good data to give a good answer.
It's a tool, not a magic wand. Exactly.
Okay, so we know how it works. We know it's not perfect. But here's the part I think will surprise people.
Yeah.
You said earlier, this isn't just for spy agencies. There are tools out there right now that anyone can use.
That's right. We're shifting from how it works to how you can use it. But, a small disclaimer. These are mainly for researchers, developers, or just the really curious.
So what's out there?
Well, if you're comfortable with a little bit of coding, there's a really popular open source library called simply Face Recognition.
Okay.
It runs on Python, you can find it on GitHub, and it is shockingly accurate. It claims 99.38% accuracy on standard tests and can identify 128 different facial points.
And how does that work? If I download it, what do I actually do?
It's pretty straightforward. You'd create a folder of known photos, labeled Mom, Dad, Steve. Then you give the program a new unknown photo. It converts all of them into those feature vectors, compares the math, and tells you, hey, this new photo contains Steve.
It's a sorting tool.
It's an incredibly powerful sorting tool, and it's completely free.
But what if I'm not a coder? What if the idea of using Python makes me break out in hives?
Then you can use commercial cloud tools like Amazon Recognition. That's recognition with AK.
And a regular person can use this.
Yep. They have a free tier. You can analyze up to 5,000 images a month for free.
5,000, that's a lot of testing.
It is. You upload images and it gives you all that analysis, the face location, the landmarks, the confidence score. But it also does something else, something called sentiment analysis.
Sentiment. You mean feelings?
It estimates emotions, it looks at the geometry of the face, the curve of the mouth, the crinkle of the eyes, and it'll output a probability. 90% chance this person is happy or sad or surprised.
Wait, so I can upload a photo of my boyfriend and ask Amazon if he's actually happy?
You could technically do that. Again, it's probability, not mind reading, but it's analyzing the physical signs of emotion.
That is incredibly powerful and also a little terrifying.
And for anyone who's really deep into it, there are frameworks like DeepFace and FaceNet. They're mainly used in academia. They let you swap out different mathematical models to see which one works best.
It's amazing how accessible this is. You always assume this stuff is locked away in a government bunker somewhere.
Not anymore. The math is out in the wild.
So we have covered a huge amount of ground.
Hmm.
From the Hollywood enhanced trope all the way to gait recognition and free tools anyone can download.
It is a lot to take in.
It is. So let's bring it all home. If someone listening takes away just 3 things from this deep dive, what should they be?
Okay, let's distill it. Practical takeaway number 1. It's geometry, not magic.
Right. It's not looking at you. It's measuring the distance between your eyes to create a numerical face print. It turns your face into a math problem.
Correct. Takeaway number 2. Hiding your face might not work.
Because of gait recognition.
Yeah.
If the camera can't see your face, the AI can still identify you by the swing of your arms or your posture. A mask isn't an invisibility cloak.
Exactly. We leave a signature just by moving. And finally, takeaway number 3. It's accessible, but imperfect.
We have free tools like Amazon recognition that anyone can try, but real-world accuracy plummets with bad lighting or weird angles. It's powerful, but it's not the oracle. It makes mistakes.
That sums it up perfectly.
You know, this whole conversation has really changed how I look at those cameras on street corners. I used to just ignore them.
It does make you more aware of your digital footprint, or I guess your physical footprint.
Definitely. And I want to leave everyone with a final thought to mull over. We focus so much on covering our faces to stay anonymous. But if an algorithm knows you by the swing of your arms or the tilt of your head, does privacy even exist in a public space anymore?
That is the big question.
Thanks for diving in with us today. Keep asking questions, watch how you walk, and we will catch you on the next deep dive.
Stay curious.